Okay, question 7. We've got Mars rover descending onto the planet Mars. Calculate the change in gravitational potential energy as it goes from P to Q. And we can see that's the bit we're interested in, 1.8 kilometres, which is going to be 1,800 metres. So we've got a unit change. Mass of the rover is in kilograms, perfect. Gravitational strength is in newtons per kilograms. Give your answer to two significant figures. So then we just shove it into GPE equals mgh. And there we go. So 1,100, this, multiplied by gravitational field strength, 3.7, multiplied that unit changed, 1,800. It then says it wants it to two significant figures. So 1, 2, and the 2 is a round down. Done. Use data to calculate the change in kinetic energy of the rover as it descends from P to Q. So let's get rid of that there. So we're going from P to Q. We can see we're going from 88 to 0. We're going to need the mass. And then we're going to put that into our K equals half mv squared. So K equals 0.5 times 1,100, the mass, multiplied by 88 squared, because that's the difference between those. So our delta V is the difference between those two velocities. And that comes to 4,259,200, and we can then round that up to 4.3 million. Next one, tricky question, the next one. The rover is slowed down safely using thrusters and a parachute. The thrusters use gas, so we've got a chemical reaction there, and the parachute is designed to be used in the atmosphere of Mars. Describe the energy changes involved in terms of the work done. So lots of students talked about the energy changes, but they didn't talk about work done. So if we talk about what work's needed, well, we've got work is being done by gravity to pull it down, and that needs to be overcome by work from, say, the parachute, and I'm going to say the thrusters. And then we can just use this to formulate our answer. So work is being done by gravity to pull it down, and then work is being done by the thrusters. And as we know, work is equivalent to energy. So now for our model answer. Work is done by the thrusters against gravity to reduce the kinetic energy. Work is done by gravity to transfer GPE to increase kinetic energy. And the chemical energy is transferred to kinetic energy and thermal energy by the thrusters. So tricky question that. From a tricky question to a nice easy one. We've got a power, we've got a time, and we've got an energy. So we're going to need our PET formula. Show that the solar panels can provide 2.16 megajoules. So gonna have to change minutes times by 60. That's in watts, happy with that. So now we just want E equals P times T. So put it all together, 1,200 for the power, 30 times 60 to get minutes into seconds, and we can see that that's megajoules, because mega is 10 to the 6. The next one, we're going to need, they convert 27% in energy, so we're going to change that to its decimal, 0.27. Calculate the solar energy received that provides 2.16 megajoules. So we know that's 2,160 million joules, and we're going to need our efficient, useful tools. So we're after the total input. Calculate the solar energy received. So that's the total that goes in, and that's this one here, total input. And now we can go, the useful output is this, divided by 0.27, and we get 8 million. That's it.